Hi guys, I am Muchakwa Tangeni with Maths XYZ, and in this lesson today we'll be dealing with the compound growth and compound decay, which is also known as the reducing balance method. Alright, if you haven't subscribed to Maths XYZ channel, please do so that you will be able to get notification when we upload videos, and also share this video with your friends and loved ones so that they can also get help from the lessons that we do. Alright, from the previous 4 lessons, we have been dealing with the simple growth and decay and also the compound growth and decay method. So you can also check those lessons as well so that you can follow up on this lesson that we'll be doing today. Alright, with the compound growth and compound decay, we have two equations, of which the only difference between these two equations is the plus and minus there. And in this equation, we have A, which is the final amount. The parameter of A is the final amount. The parameter of P is the principal or initial amount that you would have used as an investment or as when you are your initial purchase of the goods. And then I is the interest rate, which you have to divide by 100, and N is the period or time that you would have taken your investment in the account. Alright, then this equation is A is equals to P into 1 plus or minus I into an exponent of N. So it's either it's compound growth, which is appreciation of values, or compound decay, which is the depreciation of values. Alright, let's just do a question, go straight into a question and see which equation to apply where and how. Alright, this question says if an investment of 95,000 depreciate at 6.5% per annum. So we are given the initial amount which was invested, which was 95,000. This is the principal amount, which is equals to P at an interest rate of 6.5% calculated per annum. And using the reducing balance method, this is the compound decay and growth. It's also known as the reducing balance method. So the question says we must determine the value of the investment after the period of 3 years. So we actually have everything that we need so that we'll be able to answer this question. We have P, which is the principal amount, which is 95,000. We have the I, which is the interest rate of 6.5 calculated per annum, and we have the period, which is the period of 3 years right there. Then the question that we have to ask ourselves first is which equation to use. Is it the compound decay or is it the compound growth? But then with this question here, we're going to use the compound decay because of the word. It says that the investment actually depreciate over time. So that means that it's a compound decay equation. So here we have A is equals to P into 1 minus I to the exponent of N. Here, and then we're going to have P, which is 95,000. This is our initial amount. I minus 6.5%, which is the interest rate, to the exponent of N of which is equals to, it's equals to 3 years. So we actually have everything that we need so that we'll be able to solve this question. Then yeah, we just go straight into a calculator, which is 95 into 1 minus 6.5% into an exponent of 3. Then this gives a 77,653,04 cents. So here that means that this person after a period of 3 years would actually have lost, would have lost 12,346.96 cents over the period of 3 years. So this investment was actually a loss because this person after a period of 3 years, he or she would have lost an amount which is quite remarkable, amount of 12,346 after a period of 3 years. So it was actually a risk to invest in this account because at the end of the day it was a loss. Alright, let's go straight into another question and see how to apply this, which equation to apply where and how. Right. Then here we have a question. It says that if an investment of 75,000, so here we have a question which says an investment of 75,000 and 8.5% compounded annually, determine the value of investment after 9 years. So even in this question, we are given the initial amount, which is 75,000. That's our P, and we are given I, which is the interest rate calculated annually, 8.5%, and we are also given N, which is the period of 9 years. So here we are told that this investment is earning 8.5% compounded annual. That means that it's actually increasing in its value with time. So here we're gonna use the equation of compound growth, which is A is equals to P into 1 plus I to the exponent of n. So the most important things when you are dealing with financial mathematics is to know which equation to use where. So if they say that the value it would be depreciating, always know that you have to use an equation of decay. But then if you have if they tells you that the investment ends like this question here is just if an investment ends 8.5% are compounded annually, it already tells us that this investment is actually a gain. So you use the compound or the simple growth method. So that's the tricky thing, to know which equation to use when you are solving financial mathematics problems. So here we have A is equals to P into 1 plus I to the exponent of n, of which P, which is the initial amount, principal amount, it's 75,000, into 1 plus 8.5%. Remember I said you must divide by 100, and then to an exponent of 9 years. So that's 9 years. So let's see how much this person would have gained after a period of 9 years. So that's 75,000 into 1 plus 8.5% into an exponent of 9. So this person now after 9 years will be having 156,289,118 cent. So that means that after a period of 9 years, this person would have gained 81,289 rands. So that means that this person has actually gained in their investment that they have made in period of in 9 years periods. They would have gained an amount which is close to 82,000. All right, this was a good investment. Then let's check this one, which is the last question. It says determine the rate of depreciation. So that already, if they say depreciation, then we know that we'll be using an equation which is a decay, simple decay or compound decay equation. And then the interest, determine the rate, we know that we have to be looking for an interest rate that will be used if a car depreciates from 120,000 to 63,327.80 cents in a period of 5 years on reducing method. So it already tells us that we'll be using the compound method, but then we already know because it says depreciation, so we'll be using the compound decay method, which is also the reducing balance method. And we'll be in this question we are also given the period, which is 5 years. What we are not given and what we're looking for is the I, which is the interest rate. So here we have A is equals to P into 1 minus I to the exponent of n. We are actually looking for I. And then here we have 63,327 is equals to 120,000 into 1 minus I, which is what we're looking for, into a period of 5 years, the exponent of 5. Then here we'll divide with 120,000. 120,000 divided by 120,000 on both sides of the equal sign. So this will cancel out. Alright, then using my calculator, what will I get? Remember I told you guys in the previous lesson that we did that when you are dealing with financial mathematics problems, please do not round off your answers until you get your final answers, because it won't give you the right decimals when you get to the final answer. So it's better not to round off, but you just save in your calculator. So we have 63,327.80 cent. I actually forgot the 80 cent there. 80 cent divided by 120,000. This will give it's 0.5277 going on and on. So I will just save this in my calculator. I save it at A. I hope you guys know how to save. You actually just press shift and then RCL there and choose any alphabet in your calculator. So I choose the alphabet. They are actually written in pink in this calculator if you are using a casio like mine. So they are actually written in pink. So this I have saved it in A, but to get it I just play recall and then A, then I will have the amount, the number there. Alright, then from here we have 0.522, which I have saved at A in my calculator. I will just write it there so that I don't forget. It's equals to 1 minus I to the exponent of 5. Then introducing the fifth root here, it will be like that. Introducing the fifth root there, it will be that. Then the fifth root of this, which is 5, and then recall of a, we have 0, 0,87799 going there. And then remember I told you guys that I will just save, then I will just have to press shift, store, and then this time I will choose the letter of B. Then I know this is saved at B. It's equals to 1 minus I. Then my I here will be I is equals to 1 minus recall B. 1 minus recall B, which will give 0,12 going on and on. Then multiply by 100. I told you guys that the interest rate has to be in terms of percentage. Then multiply by 100. This is equals to 12%. Then at the end of the day, that the interest rate which was used to depreciate the value of this car, it was 12% over the period of 5 years. The car moved from 120,000 to 63,000 in 5 years period. So it was almost the original amount which was used to purchase the car initially. Then here, the investment of buying this car, we can't say it's bad because this person has been using this car, driving all around, getting there and there. But then at the end of 5 years, it actually has a value which was lower, quite lower than the value that was used to actually purchase it in the first place. Alright guys, I hope you understood everything, and now you can make a distinguish between the compound growth and the compound decay, and you know where to apply which equation and how to apply it. Alright guys, if you didn't understand anything from this lesson, please drop us a comment and then we'll have a follow-up on it. And also remember to share this video so that other people can also get help from the lesson that we just did today. Alright guys, bye.